Welcome back, everybody. In this video, we're going to take our next look at the next topic with DMVPN, which is going to be per tunnel quality of service. Now, this one's going to take us a little bit to get the configuration in place, and I'm going to talk a little bit up front about how this actually works and the details behind it. But it's pretty straightforward for the most part. You just have to understand logically what's happening. So I'm going to go ahead and bust out the pen tool and talk a little bit about this because it's documented fairly well, but if you've never dealt with it, it can be a little convoluted at times. So the way that this works in simplified terms is this. Normally, quality of service is going to be applied either in or out on a particular interface with a policy map, and the service policy is going to call the policy map. The policy map is going to be configured in such a way to affect some sort of traffic. So from the logic is going to be the class map is going to match. The policy map is going to enforce or apply some sort of policy, and then the service policy is going to apply the policy map, right? So that's going to be the structure we use. Now, there is some overlap between these two variations, the class map and the policy map, with a technique known as zone-based firewall, which is the inspect command. We're not inspecting the traffic at all. We're not doing any type of zone-based firewalling or anything like that, which is using the modular policy framework capability. Although we will be talking about that feature in an upcoming set of videos, but for right now, we're not going to play with that. What we're going to be focusing on, namely here, is understanding how per tunnel quality of service comes into play. Now, the problem that we have here is that on this side here, we have a 1 gigabit connection, right? We have a 1 gigabit connection here. Now, that's pretty common for data center side connections, especially on decent sized enterprise environments. However, the spoke side, not so much. You could have anything from a 1.5 megabit connection, or a T1, all the way up to 1 gigabit. I mean, it's anything in between there is certainly possible. And that could be applied over here as well on this spoke and on this spoke. Well, that brings us to the reason why per tunnel quality of service was developed in the first place. So the logic of this is to basically create a policy that can be mapped to a group. And you create a group. The group is tied to a map that calls a service policy that enforces a policy map. It's a little bit of a convoluted configuration. You'll see what I mean by it. The idea is you create a policy map to do something. Like, for example, you would normally I would configure this with a shaper, and the shaper would be limited to send the amount of data that the remote spoke can receive. So if this side right here is 1.5 megabits per second, this guy over here is 100 megabits per second, and let's say, for instance, this side over here is 50 megabits per second. So we have three different variations in the capability. I'm going to set a shaper for each one. I'm going to have a policy map for the 1.5 connection. I'm going to have and the shaper is going to be set to send no more than 1.5 megabits per second, and then whatever policing values or whatever prioritization values I need for any of the traffic that's getting matched inside of there. You can do it as little as saying, I don't want to send any more than 1.5 megabits per second towards this particular spoke. That alone is enough. But if you want to do prioritization and stuff like that, I found that it's more efficient just to have the shaper on there than it is to try to do any type of QoS marking. I have done this over both internet-based transport and MPLS. We didn't really see any difference between internet or MPLS even though we were tagging it. We didn't have any encryption in place here. This was straight up, there was no encryption at all. So no crypto applied over the MPLS portion of it. We had the one customer that I worked with this on the most. There was no encryption over the MPLS backbone. But when in situations like that, it became kind of interesting. So we had a policy map that was sped up 1.5. We can create this is going to decide to bug out on me, but you can do the same thing, and we can have another policy map that is set up for 50 megabits per second. So a policy map of 50, and then we set a shaper to 50 million bits per second, or 50 meg, and then we do a policy map of 100, and we do a shaper of 100. Trying to count my zeros here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that would be 1,000, 10 meg, one more. There we go. So now we have our 100 megabit. So the idea here is then you would call this policy map from a group mapping. And the group mapping gets applied underneath the tunnel interface. And then you configure the spoke side to join that group. So you would say group 1.5, group 100, and then over here this would be group 50. And that's going to send a signal via NHRP to say, I wanted to join that particular service policy. So any traffic that is sent outbound to that particular node is going to be shaped to that particular value. And that's basically how it's going to happen. You could put other values in there as well. You can do, your prioritization bits. You can match on a particular subset of traffic and so on and so forth. This is going to tie into the hierarchical queuing framework. And the HQF essentially is going to allow you to do a parent policy and a child policy. The way that these work out is the parent policy is going to be done underneath what they call the class-default. And what's going to end up happening is you're going to have a primary. This is going to be the parent policy, and then you're going to say a service policy, and you're going to call the child policy from that. The child policy is actually going to be a policy map like it is right here. And it might be a little confusing, but I'm going to kind of tie it all back together, and you'll see what I mean. In this case here, we're not really going to go to that level of detail. You can. But instead of doing the shaper, we're going to set a policer to a rate of 8K per connection. You might say, why are we doing that? Well, the main reason we're doing that is because we want to actually see the pings get dropped. And we're going to do the same thing to the spoke side. We're going to configure the same thing, and we're going to have the hubs register the spokes. Like I said, this is going to take a little while for us to get the configuration in place, but it is it's an involved config. But once it's in place, because you can do spoke-to-spoke communication and stuff like that. So that's basically how we're going to go about doing it. So without any further ado, let's go ahead and get started with the config. It's going to take us a while to get through this. Let's go ahead and wipe the screen and bring over Secure CRT. So we're going to start on the hub side. And because everything is configured to go through iOS 22, that's where I'm going to start my config. So we're going to do that. We're going to do a show DMVPN. And so we have our three hubs, or three spokes, I should say, show IP, EIGRP neighbors. I have my three EIGRP peers up and running. We're good to go there. So I'm going to create a class map. Actually, the first thing I'm going to do is type in IP access list extended. I'm going to call this ICMP. We're going to match simply on ping. We're going to say permit ICMP any, and we're going to say class map CM is going to be ICMP. Actually, we're going to say match any. Even though we're only matching on one specific thing, I like to do the match or instead of the match and. CM underscore ICMP. I've been burned many times by forgetting to do the match any command and then having a QoS policy not work at all. So we're going to type in match access group name ICMP. We're going to exit out of here and type in a policy map PM, and we're going to specify here in this case here we're going to say hub to spoke, and we're going to say class is CM underscore ICMP, and we're going to police down to a rate of 8K with the conform action being transmit and the exceed action being drop. So very simple QoS policy. So we have that. So if I was to do show run section class map, policy map, or access list, give that a moment to go grab all of those details, and I'm going to kind of rebuild it for you logically. So the access list is going to help us match on the type of traffic, and the reason why we're using an access list and not NBAR or network-based application recognition is I found that the virtual routers tend to have a hard time of doing really good classification. So an ACL matching on the traffic for us is going to be that much more efficient. So that's why we do that. You can do it with NBAR in production if you'd like, but I find it works better with an ACL. Then we're going to call that ACL from a class map right here. And then we're going to create a policy map, and underneath that class, we're going to call the class map. From that, we're going to set police the committed information rate down to 8K, and we're going to set the conform action to transmit and the exceed action to drop. So any traffic over 8K per second is going to get dropped. We're going to go to interface tunnel 1, and I'm going to type in the NHRP and the group name. And if I was on the remote end, this is where I would type these configs in. I would specify the group that I want to join. Here I have to say map to a group mapping. The NHRP group in this case here is going to be, we're going to say spoke, and we're going to say the service policy is going to be the policy map name, which is PM hub to spoke. Okay, we're going to do that. And I forgot to say output. And by the way, you have to specify the output. It's an output only policy and the policy map name. So now that we've done that, now I'm going to go over to 24, and I'm going to say NHRP group spoke. So on this side here, I'm going to go to global config, interface tunnel 1, NHRP group spoke. Okay, do the same thing on CSR 11, interface tunnel 1, NHRP group spoke. And same thing with 25. Interface tunnel 1, NHRP group spoke. Okay, now I'm going to go back to 22, and I'm going to jump out of global config, and I'm going to show DMVPN detail. Now, as you can see, nothing's really happening. Nothing has triggered. We actually have to go, we can do this one of two ways. We can either bounce the hub, and when I've done this in the past, this was the quickest and easiest way to get everybody to join at one time, or you can individually bounce the spokes. It's your choice. Just to speed this process up, we're going to bounce the hub. So we're going to go to config T, interface tunnel 1. We're going to shut it down. Give that a couple seconds to do its job. And then we're going to say no shut. We're going to learn EIGRP adjacencies here in just a few seconds. And we might not have given it enough time. Show IP EIGRP neighbor. I think I might have jumped the gun. Oh, there we go. I didn't. So right now we are negotiating. There we go. So we're squared away now. So show DMVPN detail. And now we have connectivity. So here we have in the DMVPN detail, we have communication from the hub to the spokes. We have the NHRP group of spoke. So now if we do a show policy map multi-point, we are going to send any type of communication from the hub down to the spoke is going to be affected by this policy. Okay? So we do that. Then what we have to go do is test it. So from iOS 34, we're going to ping 33.33.33.33, and we're going to repeat the count 100 times and hit the enter key. So right now nothing's triggering, right? If we were to go to iOS 22 and hit the enter key, we're going to go through here. We're going to see that there are some packets being matched, right? Class map is matching on some data, and so we know it's going that direction, but we haven't conform packets is 100. We haven't exceeded 8K. So that means I have to go back to 34. We have to actually bump this up, and we have to say the size is going to be 1500, so a full payload. And then we do it, and then we're going to start seeing packet drops because we exceeded 8K, and now we're seeing packet drops. We go back over to 22, we hit the up arrow, and we're going to start seeing packet drops right here. We're seeing exceed action is to drop. So it is working the way that we expected it to. So we have that. I'm going to go Control-Shift-6 on that to break that out. Now that's hub to spoke. Spoke to hub is a little bit different. So we have to take the exact same logic. Now, spoke to spoke communication, not really going to be feasible here. Unless you were to create per spoke policy maps and class maps, and then have the spokes join each other's groups. To do spoke-to-spoke communication, if you want that to happen, it's better to do an interesting traffic type of situation, have the traffic go through the hub and then to the spoke. You can only do one group mapping per tunnel. So if you want to do, that's why it's called per tunnel QoS. It's not, a lot of people misconceive that logic in thinking that if I'm going to do, for every spoke, I'm going to have a separate tunnel, a different QoS policy. No, it's one QoS policy per tunnel. So if I wanted to do any type of inflection to where if I wanted to, if I don't care about the hub to spoke communication, just let it go, then that's fine. But the spokes are going to have to join that. That's the whole point. Isn't necessarily spoke to spoke communication. And a lot of times you're not going to be looking for quality of service enforcement on that because it's going to be direct device or spoke to spoke communication. You're going to be more or less interested in the hub to spoke because usually the hub is going to have a much higher throughput than the spoke will, and that's where it really comes into play. So let's go ahead and configure the spoke to hub communication because you can do it bidirectionally. On 22, I'm going to go ahead and I'm going to literally take this syntax that we have up here. Go find it real quick. Lots of output. So we're just going to grab this config right there. We're going to go to 24. And we're going to copy and paste all this config in here. We're going to go do show run interface tunnel 1, and you can see that we have the NHRP group of spoke. We're going to go to interface tunnel 1 and type in NHRP map group to hub, and we're going to say that the service policy is going to be output, and the name is going to be right here, hub to spoke. Even though the name or the name is irrelevant in this case here, it's the directionality that we're applying it. So we're going to do that, and I'm going to go over to 22, and underneath interface tunnel 1, I'm going to type in the NHRP group that we're going to join is going to be hub. Now if I do this on 24, show DMVPN detail, I am looking right in here, and right now I don't have anything happening. So I'm going to go to global config, interface tunnel 1. I'm going to shut down the tunnel. And I'm going to bring up the tunnel. So what's going to end up happening now is that's going to sync, and the remote end is going to grab it. Because it's an NHRP mapping, so it's got to be an NHRP registration. And so now we have 22 has joined the hub NHRP group. We do a show policy map, multi-point. We're going to have this set up like that. We're going to go to 33, and we're going to do a ping to 172.16.101.34, sourcing from loopback 0, and we're going to repeat it 100 times with a size of, actually let's do 20 pings and a size of 1500. And so right away we start to see the results of our actions happening. So here we are matching on the traffic, which is exactly what we're expecting to see. And so we had a few drops in traffic. So now, but if I went to, for example, 20.20.20.20, it's not going to have the same effect. And you might say, well, why is it not going to have the same effect? Well, because where I'm sending the traffic has not joined this specific group. If I wanted it to join this specific group, I'd have to go configure the spoke to join the specific group. So let's go do that real quick. We'll go to 25. We'll type in this case here, we can't. So I jumped the gun a little bit. So we would have to, well, we could do it. It's for the sake of demonstration purposes, I'll just type in the command hub and drop out of global config. We'll go back to 24 and we'll do a show DMVPN detail. And now we have 25. I've actually got to bounce the tunnel. So interface tunnel 1. We're going to shut the tunnel down. Then no shut the tunnel. That brings the tunnel back online. So it's going to do its thing. And if I go back to 24, we're going to see that momentarily. This should have, you might have to wait for it to do, let's see, 24. It may not do it. I don't see 20.25.0.0.25 showing up. Yeah, it's apparently not doing what I want it to do. Because if I was to try to do this again, the policy map is not applying. So if I was to do that ping, or I'm sorry, from 33, if I was to do that ping again, it's not going to have any effect because it's not being applied. But you wouldn't do that normally anyway. You would set the group to be spoke, and then you'd have on 22 you would have the show DMVPN detail. You'd have 25 and all of these. See, in this case here, 25's got the wrong connection, so I have to go bounce 25 again. So we're going to shut it down. And no shut it. And now that's good to go. We'll go back to 22. And so we should have 25 join the correct, and it is. 25 is now joined again. So now if I went back to 33, 4, and I went 20, 20, 20. Let's do a 20 here. 20.20.20.20. You're going to see it hit that same point and start to time out. So hub to spoke and spoke to hub, it works very, very well. Spoke to spoke, not so much. But it was never really designed to do spoke to spoke because they're on-demand tunnels. Could you create another variation of that and create a service policy output? Maybe. I mean, you're welcome to give that a shot. I don't know if that would affect or have an effect per se on spoke-to-spoke communication. I've never actually tried it, but at least I don't remember having tried that. But it's certainly an option for you if you would like to try it out. But I wanted to demonstrate how this would come into play and stuff like that. So until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next one.